Hello friends, welcome back to another video. In this video we are going to hack the Witcher 3, and in that particularly we are going to hack the carry weight. So we can see that in the game we are restricted to have a maximum carry weight of I guess 60. So today we are going to hack the amount of maximum carry weight. So let's begin doing it. Let's wait for the game to load. And in this game we are going to hack the value of carry weight by doing a AOB scan. Let me show you how we do it. Alright, I think we are in the middle of some mission. Let me reduce the volume. Let's set as a cheating into the game. Alright. Now if you see the the maximum value was given by 90, so we are restricted to have a maximum value of 90. Now what I'm going to do is we are going to change it to a bigger value. So a friend of mine has done has searched for the value in different kinds of values. He put a 60 over here. He tried for byte, 2 bytes and binary and all, 8 bytes and different things, float. Even he tried for the doublet sims. So finally he ended up with few array of bytes. These array of bytes are the values of that maximum value. Each of one is specific to a different kind of version of the game. So for my version of Witcher 3, the first AOB is working. You might try with different AOBs in this list. So I'm going to show you how to do it. Select anyone from the list. I'll put the list in the description. Select anyone of the list, go to the value type to array of bytes and check this hex checkbox and paste the array of bytes from the above list. I'll put the list in the description and make this writable checkbox into box, not a tick. So a box means that it is both readable and writable, and then do a first scan and we'll get the value of the maximum carry weight in hex in the memory. My PC became a little bit laggy. Let's wait for a second. Alright, so we got the array of byte. What you could do is you could directly right click on it and go to browse the memory region, or use a Ctrl B shortcut to do it. So this is the thing which we have searched for. So what you could do is you could directly bring it down, and to know that if it is exact the correct value which you are searching for or not, change its type to make it into a float, I guess, and make it into display in one second, show in decimal. So you could see this is a value of 60. So now you could put a value of which you like, let's say 9000. Let's refresh the inventory. See, the maximum value of the the carry weight has changed. So you have achieved the hack of doing it. Now you might be thinking that this is again a dynamic value. So again, what we could do is again go into the memory view, which was already over here, and you could do something like what accesses this, not what writes this. Why? Because the value is not being written every time, it's only being accessed. The reason is that the maximum value is always constant for a game, so it will not be written. It will be written only when the game is loaded once, so it will be only accessed. So what you could do is right click it and open this as a debugger, and what opcode accesses. You could, let's say, to change it, you could drop something. Let us drop something which changes my weight. Let us drop this. Did my weight change? No. Yes, my weight changed. So now we could go out of the screen. See, these two instructions are accessing my max value. Excuse me. So you could go to the disassembler and you could directly write a script for it. And let's see, table framework. I prefer doing it in coding injection way, but then many people do AOB injection. It depends on the person who uses it. I feel this as easier. So here what we do is we are going to move a bigger value. So we are going to move a bigger value, let's say this much of value, and to make it as an int, since we don't want it to be a hexadecimal value. Let's remove all the unnecessary things. That's it. And as I said, never hit this button execute, always assign it to the cheat table and close it. We are just doing a trial and error with this opcode. Let us see if this works. If not, we'll try the first one. let's refresh the inventory. So that didn't work. So let's remove the script and try out the first one in the similar way. So the second one hasn't got anything to do with our actual code, and the process of hacking, as we all know, is just by doing trial and error. Just guess something, assume something, it might or might not happen, experiment, get the things done. Of, let's say, this much, assign it to a current sheet table. Okay, let's alright. So I think we messed up something. Let me try to do it with the other script. Let me dig around with the code over here a little bit. Alright friends, the problem was that sorry, the value type of this value is float, but then it's showing us as an integer value. That's the problem. So what we need to do is we need to write a script for float. And the second thing which I observed is that this opcode is shared. See, if you go into the game, this opcode will be shared by many other things. See, these many number of addresses, different addresses are accessing the same opcode, so we can't directly script it. So we need a factor to differentiate our address. I think this is one of the address among the list. You see 285D 17. Let's make it into float. Right. C F8C. So these many things are already using this, and to overcome this, what we could do is we'll use a dissected data structure, and I have done all the things, and I have seen that the preceding next address to our value always remains 60. So let us say that RBX plus RSI plus 0C is having the present value. Let me write it down. This corresponding thing is having a value of present value, let's say present value, and then this offset plus fourth offset, I have seen it as always being 60.00. so what we could do is we could always check for plus 4. So we could always check for the plus fourth value. If it is 60, we want to put a value of, let's say, make this much of value, and as I said, it isn't an int, we should change it to a float. These are the two changes we should take care while using this instruction. Let's script it now. So what we want to do is we want to compare the number at plus 4 offset. Control this one plus 04 with a float of 60.00. as I have shown you here, this is our present value and the next value is 60. So the next value, if it is not equal to 60, then we are going to do our normal execution. So jump if not equal to the original code. If you have found that it is equal, we are going to move a value of this, move a value which we would like to put it, let's say in a float, this much of value. Move that value into this and then come to the original code. This instruction would again put that value into xmm6. Perfect. Let's try doing this. Is it alright? Yes. Let's see. Try doing it. Let's see. Wow, see, the value of carry weight has become infinite, and you could play around with it. You can put any value, any bigger value, and you can try. See, the value increased still more. So by this you could like get infinite carry weight, and that's it. And if this first, what we call it, array of bytes doesn't work for you, try putting the second one over here, and remember the value type should be array of bytes and the hex should be ticked. Check for the second one and do a first scan. This scan might not result in an answer. Why? Because the first one has given me an answer. So depending on the version of the game you are using, only one of these will be working for you. So the first one worked for me, the second one might not work. As you can see, it will not work. And see the script. See, this scan didn't result any didn't give any results. So you could try any one of these and check if it is working for you or not. And that's it for the video. Give a like if you like this video, subscribe to my channel, and thanks for watching. Bye bye, and have a nice time playing Witcher 3. I like this game so much. That's it. Thanks. Bye.